Outdoor structures face constant, invisible physical stress. Wind shear, snow loads, and the sheer weight of timber constantly twist and pull at primary joints. This budget breakdown reveals a critical vulnerability. If that $100 box of screws fails, the entire $5,000 lumber investment collapses with it. This creates a difficult choice. You can pay for heavy-duty marine-grade hardware you don't actually need, or save money on cheap, coated screws that look perfectly fine today, but rot silently from the inside out. Every structural load path in a massive deck or pergola ultimately hinges on the chemical and physical integrity of its smallest components. Labels on hardware boxes often obscure the physics of how the metal actually ages. To choose correctly, we have to look past the marketing and into the metallurgy. Corrosion-resistant fasteners are standard steel wrapped in a sacrificial coating, like zinc or polymer. That barrier is designed to take the environmental damage, but it will eventually wear away entirely. Rust-proof hardware is made of solid metal alloys, like stainless steel or silicon bronze. These materials resist oxidation because the protection is a permanent part of the metal's chemical makeup. Choosing a temporary coating when the environment requires a permanent alloy guarantees an eventual joint failure. For typical inland projects, builders rely on standard pressure-treated lumber for backyard decks, fences, and pergolas. This wood is injected with harsh copper-based preservatives to stop rot, chemicals that rapidly eat through raw, unprotected steel. The standard defense here is hot-dipped galvanized or ceramic-coated screws. The thick zinc or polymer layer acts sacrificially. The wood chemicals attack the coating, leaving the structural steel core intact. These coatings fail quickly when exposed to airborne salt. For inland projects, heavily coated fasteners offer the highest return on investment, provided the structure stays far away from the ocean. Premium builds often use naturally rot-resistant woods, like cedar or redwood. These species contain natural acids and tannins that trigger a chemical reaction when they contact the zinc coating on a standard galvanized screw. This reaction produces permanent black bleeding stains that streak down the wood from every screw head, ruining the look of the project. 304 or 305 stainless steel remains inert against these tannins. Upgrading to 304 stainless preserves the aesthetic perfection of the lumber. This hardware choice acts as an insurance policy to protect the visual value of a major hardwood investment. The rules change within 5 miles of the coast or immediately adjacent to a saltwater pool. Airborne chlorides and salt spray aggressively attack metal, causing rapid pitting and crevice corrosion, even on standard 304 stainless steel. In this environment, 316 marine-grade stainless steel is the absolute baseline requirement. 316 stainless contains molybdenum. This specific element increases the metal's resistance to chloride attacks. While 316 carries a significant upfront cost premium, using cheaper metals on the coast leads to inevitable structural collapse. In the coastal strike zone, 316 grade is the mandatory baseline for structural survival. Ignore galvanic corrosion and even expensive hardware fails. This cross-section shows a stainless screw inside a galvanized bracket. Mixing dissimilar metals with moisture creates an electrochemical battery. This rapidly destroys the weaker metal, ruining the joint. Always match your screw metal to your bracket metal. The second invisible killer is the myth that 316 stainless steel is maintenance-free. Microscopic salt accumulates in the tiny crevices of screws and brackets, trapping moisture and causing tea staining over time. Marine hardware requires a regular freshwater rinse to wash away corrosive chloride buildup. 316 stainless will fail if paired with a mismatched bracket or left unwashed in a harsh salt environment. This decision framework aligns your budget with the actual environmental risk of your site. We start with the distance to saltwater. If you are within 5 miles of the coast, you require 316 stainless steel or silicon bronze. If further inland, we move to the wood type test. Are you using cedar or redwood? For these acidic woods, choose 304 or 305 stainless steel to prevent black tannin staining. For standard inland pressure-treated lumber, hot-dipped galvanized or ceramic-coated fasteners are optimal. This matrix prevents a budget build from wasting money while enforcing the safety standards required for coastal contractors. Choosing fasteners requires balancing material premiums against wood compatibility and long-term maintenance. You are buying the long-term load path and physical safety of the entire structure. When you align your hardware choices with your environment and materials, your structure is built to outlast the